Everything in nature, from the most distant quasar to the coldest chunk of cometary ice, shines in a particular wavelength of light, depending on its temperature. Many phenomena in the universe cannot be seen with the naked eye. Hot objects, such as pulsars or dying stars, emit gamma rays and X-rays, while cold objects, such as stars being formed, emit light in the infrared. These wavelengths can only be detected with very sophisticated instruments placed above our atmosphere. To observe the full spectrum of light, NASA plans to place in orbit around the Earth 4 great observatories. The first of the 4 observatories will be the Hubble Space Telescope, the most complex and powerful astronomical instrument ever built. Once in orbit, the Space Telescope will see the sky in all its splendor, stripped of the murky veil of Earth's atmosphere. At the heart of the telescope is its near-perfect 8-foot mirror. It took 2 years for Perkin-Elmer to grind, polish, and coat this single piece of glass, capable of focusing light that began its journey through space 10 billion years ago. You can think of the Space Telescope as a time machine.
Because the speed of light is finite, it takes time for light to get from there to here. Okay? If we're looking at an object that's 10 billion light years away, which is about as far as Space Telescope can see and define what it's seeing, we're seeing an object whose light left it 10 billion years ago.
The universe is believed to have begun about 15 billion years ago in an explosion called the Big Bang. Since then, everything in the universe has been moving away from us. Will galaxies and the billions of stars they contain keep getting further and further away? Or will everything eventually contract? Space Telescope will provide the first real answers to these questions. Images of the planets will be 10 times clearer than those taken by the best Earth-bound telescopes in use today. They will be similar to those relayed by the robotic spacecraft Voyager during its brief encounter with the planets. But Space Telescope, during its 15-year lifespan, will be capable of studying these objects over an extended period of time. Its fine guidance sensors can point for a period of 24 hours with a stability of 7 milliarc seconds, according to NASA's Director of Astrophysics, Dr. Charles Pellerin.
If you were to take a laser in Washington and aim it at New York City with an accuracy and stability of 7 milliarc seconds, you could have a person stand on the World Trade Center and hold a dime, and that laser would never depart from that dime. And this is with a device that's very large, weighs about 24,000 pounds, has wheels spinning, has motors moving, antennas turning. With all this activity, this device will still point to any place in space with that precision.
Quasars are probably the most distant objects in our universe. They have an energy output 1,000 times our whole galaxy. Yet all this energy appears to be coming from a point of light the size of our solar system. Where is all this energy coming from? Looking at this and other mysteries will be the second of the great telescopes, the Gamma Ray Observatory. There are some theories that say the energy coming from quasars may be caused by a huge black hole sucking up whole stars and then somehow spitting the energy back out. The third of the great observatories, the Advanced X-ray Astrophysics Facility, will study violent events of this nature, which emit vast amounts of X-rays.
We see cataclysmic violence at high energies going on in almost every astrophysical object. It's X-ray astronomy through its sensitivity to the sort of million-degree temperatures that are caused by hot plasmas that really record the violent events all over the universe. We see a whole raft of fascinating activity that is unique to the X-ray field.
The last of the 4 great observatories, the Space Infrared Telescope Facility, should complete our new view of what is going on in the universe. Its domain, the very coldest objects in the sky, where stars are born and planets begin to form. NASA's 4 great observatories, pushing technology into the 21st century to provide a new, more complete picture of our universe.